You might think you age the same between 25 and 30, and then 40 and 45, and you don't. At 44 and 60 that you see plastered on all the headlines.
Everybody changes differently. So some people are more cardio agers, some are more kidney agers, others are immune. We try to actually match people's lifestyle with their peaks of changing. So on the omega-6 is the evil fat. Lifespan is only affected by your genome 16%.
Absence of evidence isn't evidence of absence.
At some point, we could engineer people to live forever. And if you want to live forever, you're going to have.
All right, everybody, we're back with part 2 with Professor Michael Snyder. Now, if you did watch part 1, I totally fangirled. This is like a Swiftie meeting Taylor over him. He is quite an incredible researcher. He served as the chair of genetics at Stanford School of Medicine, is currently the director of Stanford's Center of Genomics and Personalized Medicine, and is one of the highest cited researchers I know. If you know what an H index is, his is 220. 60 is considered outstanding. 220 is like grotesque. I analogized him to like the Thanos of PubMed. Today, we are going to talk about the most viral paper ever published in the journal Nature Aging, about the 2 biomolecular peaks of aging. I just want to start by saying, you always have your head down in the lab, obviously grinding through work. When I looked up this study and its impact, it had what's called an altmetric score of 5,000. I checked this morning, 5,571. It's still upgoing, which makes it the most viral paper ever published in Nature Aging. And in the top few hundred of all 29 million papers ever tracked for this metric score. Did you know your paper was that viral?
I didn't know it was that viral, but I did know it had gotten a lot of attention because I am still giving interviews on this, and I gave quite a few when it first came out. I do think it happened to resonate with people, and that's why it went viral. And I guess we'll dive into this, but it does hit with, I think, with what a lot of people experience anecdotally, and then to show it scientifically probably is why it took off. Yeah.
Sorry if I caught you off guard with that intro. We can cover
No,
it if you
no
want.
worries. That's very kind of you and very, very flattering. We do science because we think it's fun,
Yeah.
and every now and then something takes off, and this one did take off the most, as far as I
Yeah.
can tell.
So let's rewind. I'm calming myself down, getting over the, Taylor Swiftie effect. Let's start with an easy question. What is aging anyway at a molecular level?
Well, good question. I mean, it's one of these things we all kind of recognize it, but how do you define it? This has actually been a bit of a problem, defining it with proper markers and such, right? You don't just use gray hair or loss of grip strength. I guess is one of the better markers. Grip strength is. Anyway, the point is that at a molecular level, we do see biochemical changes over time. And what's special about what we do is we do very, very deep measurements on people. As you know, we'll measure literally 135,000 molecules of microbe every time we sample people. And we sample them while they're healthy and track them over time. So we've been running a study on a cohort of about 109 people for quite some time now. And so we've been able to profile these changes. And one of the first lessons we learned from this is, in fact, that everybody changes differently. So some people are more cardio agers, if you will. Some are more kidney agers. Others are immune. So we all have what we call agotypes, aging patterns. And that's also very personal. It's also very actionable. So if you're a metabolic ager, for example, your glucose types of molecules may be going off, and you can take action like exercise more, lose weight, and you actually can improve those markers.
Yeah. Something you said resonated with me, which was you mentioned grip strength being a decent functional marker. And what that made me think of more generally was this idea that once a marker becomes a target, it has a risk of not being a useful marker. So I could easily train my grip strength. It's not going to make me live any longer. So to that end, how does your approach to profiling aging, we can redefine the term we defined in part 1, which is longitudinal multiomics, differ? How is it protected from that risk?
Yeah, we're taking a much broader profile on people. So we'll sample their blood, their urine, and their microbiome, if you will. from their stool samples. And we'll measure all these things in incredible detail. So we really see a lot of different pathways. We can follow this. And again, you wouldn't get that in a physician's office where they only make a limited number of measurements. They may follow your glucose and your lipid levels and things like that. That's important, don't get me wrong, but it doesn't give a very complete picture of what's going on.
Right.
Whereas we will literally track, as I say, 135,000 molecules and microbes. We're getting a very complete picture of people's metabolism, their heart markers in there, cardiovascular disease. There's all kinds of markers in these measurements. And so by tracking people, we can see how they're changing. And as I say, everybody changes differently. Now, having said that, what the reason the paper went viral was we just asked a simple question. Maybe people aren't just gradually getting older. Maybe there are certain changes that are occurring more at certain ages than others. And so
Yeah.
we did what's called nonlinear analysis of these various molecules. And we discovered that, in fact, there are lots of changing patterns there. And then we asked where are the most changes occurring, and we saw two bursts, if you will, one centered around 44, but don't take that number too seriously. That's a broad range, and one at 60. So that was the big finding, that we saw two areas where there are particularly high numbers of changes occurring.
Right. So just to reinforce that point, you might think you age the same between 25 and 30 and then 40 and 45, and you don't. That is what's so remarkable about this study. They identified two peaks of aging. And just to kind of also reinforce, while one might think that patterns in, you mentioned you track like 135,000 molecules, are linear over time. When you looked at all these molecules, how many actually followed a linear pattern, which you'd think would be in, the intuitive direction? What proportion?
Very few. It's like 8%, some really low number.
Yeah.
So most actually show nonlinear changes. Now, it's true our assays are pretty sensitive. Some of that is subtle, but nonetheless, some of it's pretty dramatic.
Yeah.
And we picked up all of that. So the point is, very few of your molecules are showing gradual linear changes. There really are differences at different ages.
Right. And obviously, you had a group of people on who you were, conducting these studies, and the peaks correspond to presumably the group means, the group averages. So, my next question is like, how much noise is there? So, if you compare, I guess I'm under 44, but people you take a group of 70-year-olds, how much noise is there on where to their peak of aging? If we say everybody has two peaks for the sake of argument, is it possible one person's peak is at 35, 30, 40, 45, 50? And how would anybody even know?
Yeah, we assume that's the case. So there is some noise there, and that's the study we're running now. We've been actually collecting more data on these folks, so we're about to analyze even more data on the same folks as well as add others. So we're going to pin that down where we try to actually match people's lifestyle with their peaks of changing. So backing up a little bit, what are the changes that are occurring? Well, at age 60, those changes we did expect, by the way. Those are things like immune response. We know that your immune system declines when you hit your 60s. That's why you get vaccinated, of course. Sarcopenia, loss of muscle mass, that occurs, and most people know that as you hit your 60s. We did see a lot of other things as well: kidney function, oxidative stress, other things were shifting as people hit their 60s that weren't as well documented. So we did pick those up. Now, the one at 44 was, again, not documented in the literature, but I think anecdotally, most people have been through this. We saw shifts once again in muscle and extracellular matrix, which are things that hold both your muscle and your skin together. We saw changes in lipid metabolism, caffeine and alcohol metabolism in this peak around 44. And so it's not 100% clear what's causing that one. We think the one later at 60s is because you do have immune decline. That's well known, and loss of muscle mass.
Yeah.
And I'm a big believer in strength training as a way of throughout your life to keep this up. I only started probably about 9 years ago now. But back on one around 44, it's not as clear what's going on there. Why should there be a peak? And my own view is that it probably is a lifestyle effect, that I think people are super active in their teens and 20s, and they slow down a bit as they hit, work on their career and family through their 30s and 40s. And I think it catches up with them. That's our hypothesis, if you will. So going back to your earlier question, we're trying to match people's lifestyle with those specific changes now at an individual level to see, well, as somebody who is super active, does that peak get pushed off to their 50s or maybe never exist at all if they can really keep it up enough, that kind of thing. And also, I think there's a tendency to lose good nutritional habits, if you will, as you start getting very busy. And so I think same thing, if we can see people who are manage to keep their ultra processed foods down and that sort of thing, maybe they will either show less of a burst, a personal burst, or maybe simply or delay
Right.
that burst,
Yeah.
one or the other.
So I want to get into some of the specific findings and actionable insights, but really want to reinforce what I think you're saying, which is, the peaks at 44 and 60 that you see plastered on all the headlines from last year, even my own thumbnail, it gives a sense that this is cemented somehow. And what I hear you saying is, well, this is a fascinating observation, but we don't know what contributes to it. There may be some element of it's maybe baked into the genome, maybe, but you sound like you're predicting, and I would tend to agree, that there are probably convergent behavioral factors that will allow us to figure out with more precision. We're talking all about precision medicine in part one, how to modify these peaks, shift these peaks, or just erase the peaks. Is that a
We
fair
believe
characterization?
so. Yeah, yeah, absolutely, Nick. We believe so because there's genetic studies that show lifespan is only affected by your genome 16%. So 16% of your lifespan depends on genetics. That means the rest is on lifestyle and environmental exposure. It's a much bigger factor. And so I'm a big believer we should be able to control this with our lifestyle. Now, it is the case, there's some data out there now that if you want to live to be 100 or longer, genetics is a bigger deal. That then accounts for about 60%. But even still, even in that group, 40% is due to lifestyle.
Right.
So the point is that I think how we live is a big deal. And I think more and more people are becoming aware of that. But it's, I wish I knew this 40 years ago. I probably would have done a little better. Hard to say because when you're young, you think you're brash and you're invincible. But
Yeah.
anyway, I certainly try and live a better lifestyle now. And I hope that's going to, keep,
Yeah.
it has seemed to help with my various metabolic markers and things.
Yeah. Well, your brain's in tip-top shape, obviously. That's important as we age. Yeah, I guess I would say, taking care of yourself, healthy lifestyle is necessary, but not sufficient if you want to live to be 110. But
Yeah.
if you slow your aging curve, you might, be able to eke out that time so technology can give us that chance. But
Yeah. Well,
with that,
backing up, I forgot one thing to that, Nick. Again, because medicine's very reactive, meaning we treat people when they're ill rather than keep them healthy. What we have now in the US and in Europe, in Western society, is that people's health span, the time they live to be healthy,
Mhm.
is about 11 to 15 years shorter than their lifespan, meaning they're spending their last decade of life unhealthy. Now, of course, it depends how you define health span. A lot of people say two or more comorbidities is one way to define that. But the point is that people are living a lot of the end of life, if you will, in an unhealthy fashion. And that's crazy, right? We really want people to be living long, healthy lives and then, just pass
Yeah.
away. Or at some point, I'm pretty confident we could engineer people to live forever, but that's a whole nother podcast, I'm sure.
I think you, me, and Brian Johnson need to get in a room and discuss this. But I tend to agree. I think we probably all have different philosophies on nutrition and stuff, but it's an engineering problem. It's not
It is.
physiologically impossible.
That's exactly
So
what I say. Yeah, yeah.
yeah, so I'm not the scientific engineer. That's you. So what I take from this is you are going to figure out how I'm not going to die.
Now, before we move on, a quick tangent. I want to thank the sponsor of this video, Chapter. I know sponsor messages can feel like a pill, but bear with me, this one's important and could save your life or your parents' lives. First, here's a transparency statement from me. After 2 doctorates and over a decade of higher education, The US healthcare system and insurance markets are still the most complex thing in the universe to me. It's more complex than if the Krebs cycle swallowed the clotting cascade and chased it down with a glass of quantum biology. But here's why this really matters. The right health insurance can literally improve all-cause mortality. And that's not just a correlation, there's causal evidence for this. The methods are kind of complicated, and you can see this nuanced note letter for more. I've linked it in the caption. Anyway, that is why Chapter exists. It was founded by people whose parents were scammed by sleazy Medicare brokers, and they vowed to fix the system and actually built a model that does just that. They search every Medicare plan to match you with the right fit for you. And Chapter is fully independent. It searches every Medicare plan available to find the one that truly fits your needs and priorities. And you'll always talk with a real human too. And their advisors aren't compensated based on steering you to a particular plan. That means the results are savings for you in 3 currencies. Money. The average user saves $1,100 per year. Savings in stress. It's always nice to talk to a real human and have them handle it for you. And even maybe savings in life years. Now, if this could help you or a loved one, we've set up a phone line. 815-STAY-CURE, as in stay curious. That's 815-782-9287. Metabolic health is life insurance of a form, but you also need the right real health insurance. Thanks for listening. Back to your main program.
I'm going to hold you to that. But with getting into some more specifics, I want to talk about, you mentioned alcohol, you mentioned caffeine, we mentioned antioxidants, and catabolic state in muscle. So I want to make sure to hit on those things. Let's start with alcohol. What was the finding there?
Yeah, that was one of those things that shifts around 40, alcohol and caffeine metabolism. And I think anecdotally that's true. It was true for me on the caffeine, meaning I became super sensitive as I hit my 40s. I stopped drinking coffee after noon because I couldn't anymore. Whereas when I was young, I would just drink coffee even right before bed, no big deal. So for me, that was personally true. And I've known other people it's been true for as well. Alcohol, a lot of people have had that same issue. You know, they drink, they're binge drinkers. They drink like mad when they're young. And then suddenly they hit their 40s and discover that, you know, maybe that tying one on doesn't have the same effect it did 20 years earlier. So I think people, again, anecdotally saw that. For me, one of the more interesting ones, and maybe we can dive into this more if you want, is the lipid metabolism shift that hits in the 40s, which I thought was really fascinating. And I think it fits with the idea that people's fat, deposition does seem to shift in terms of their body sites and things. If you look at people's shapes, they do shift quite a bit. It's not the same in every person. I don't fully understand that. And something I'd like to dig into more. Actually, our lab is studying this more, and I know it overlaps with your interests. But we did see big changes there as well. And that was true for me. That's when my cholesterol really started going off in my 40s. I should have acted on a lot sooner than I did. I wound up with a calcium score of 1,000 because I was kind of slow on it.
I'm sorry to hear that. But yeah,
Well, it's fine because it's all calcified. I don't have the. I know this is a little esoteric, perhaps, for your listeners.
You're not going to pop off a clot.
Yeah, exactly. It's all calcified. I don't have the loose stuff floating around that you would worry about that could pop off a clot, as you say.
Yeah. Well, some new research on deoxycholic acid, microbiome, and blood clotting, which we should talk about later, another time. But yeah, let's dig into the lipids a little bit more. I had some specific questions around that, with particular emphasis on omega fats. And I'm going to frame this up for you because I know you're not involved in the social media drama, but one area of particular interest, I think, for the community is not just omega-3 fats, but omega-6 fats. I don't know if you know, there's a controversy over like one side's like, this is the death oil, the seed oil, omega-6 are poisoning you. And then there's another side that is like, seed oils are fine, more omega-6 is better. I've been delving into it quite a bit. I've done distinct pieces of content on it. I actually got just back from Tampa with a 3.5-hour debate around seed oils with a guy named, I don't know if you know, Paul Saladino. But my high-level takeaway, and then I want to relate it to this research, is these fats are not just structural. They're not just fuel molecules. They are precursor biomolecules to which many, many things can happen. You can have your omega-6 get turned into a very cytotoxic compound for HNE, or get oxidized by enzymes that are made from fat tissue, or in brown fat and beige fat get turned into signaling hormones, one called, 12-13-di-HOME, but that have cardioprotective effects. So the reason I bring this up is because I've been thinking more and more about omega-6 fats in particular in the context of individual metabolic cases, how much body fat you have, what age you are. I'm going to more or less just let you respond to that concept, but a question I want to hit on that I think will just be of interest to people is, do you think these aging peaks that you discover could have within them a signature connoting something to the effect of, past a certain age peak, you might be more sensitive to certain fatty acids in the diet?
Yeah. So you're hitting a lot in there.
Sorry, that
And
was
so,
a
no,
monologue more
that's
than a question.
no, it's all great. I think on the omega sixes, you're absolutely right. They were always viewed as evil, the evil fats, and now it is shifting, and people are trying to understand more. And it's a series of molecules. First of all, it's not one simple molecule. And I think this is where we need more research. We need to break this down and study this further. Same with lipid biology in general, I would argue, is very understudied. There's long chain and short chain, medium chain fatty acids that all have very, very different effects. So I think the whole area needs to be studied. And as you point out, it's integrated into all aspects of human biology, and how all this works is not so clear. And so of course, there are studies coming out, as you point out. Everybody agrees omega-3s are good, and you want to keep your omega-3s up, eat your fish oil, important for cognition, and you probably know your brain and your eyes have a ton of omega-3 in them. So it's really important, I think, for both those to keep those levels up. That one everybody can agree with. I think the omega-6 stuff, as you point out, is now being recognized as a beneficial, if you look at it in the right context. And we need to break that down. You probably know this space a lot better than I do. So I think we do need to understand it. So on the last point you raised, how does that relate to aging? I'm sure it 100% relates to aging, because our metabolic enzymes, they're some of the most dramatic things that are shifting throughout, our lives. And at least when we look at this patterns data. And so again, the big shift in the 40s I mentioned, and there's and also there was some shifts in the 80s with the antioxidant stuff. So we think that there are these big effects, and that one I haven't drilled in as much for thinking about what the right mitigation effects are.
Yeah.
But I'm sure that there should be dietary interventions you could do to help improve that.
Yeah. I wasn't trying to pin specifics on protocols yet. It's just more the idea of how complex this is, because I think both extremes are wrong. To say seed oils are totally fine, wrong. To say omega-6 is the worst, also wrong. And I think one thing short form media, social media has trouble doing is saying, look, there are data here that are opposing, and we don't need to reconcile them immediately. We just need to say, look, they are opposing. Now, what are the factors that could explain, what's going on here? And so that's the way I feel about omega-6 fats. Or I'll just bring this up. This is a
I
nerd.
can give you another one too. An
Yeah.
example, carnitine. Carnitine,
Yeah.
can look really good in certain situations, and carnitine really bad if you have too much with red meats and things. You convert it to TMAO, and it's been associated with heart attacks. And yet there's other instances where carnitine is very, very beneficial. So it's probably getting the doses right and the context right. So,
Yeah.
and I'll bet that's very true of the omega-6s as well.
Yeah, just because you mentioned it, before we go on to antioxidants, I wouldn't expect this on your radar. I was going down a rabbit hole. There were 3 papers out in Cell Metabolism. You will love this, but they were all about mitochondrial transfer, intercell, so between cell and between tissue. There was one paper out, and basically what it showed is that adipocytes in fat tissue give off mitochondria to macrophages. And that this is actually important for energy homeostasis. And if you disrupt this process, there's a decrease in energy expenditure and fat gain. But then they were looking at fatty acids, this was a separate paper, and how they interact with this process. And what they found was an opposite effect, whereby long chain fatty acids, both saturated and unsaturated, so linoleic acid and stearic and palmitic and oleic, I think it was, they did 4 long chains, blocked the transfer. But medium chains, I think it was lauric and myristic, enhanced the transfer, which is crazy. And then, now I'm way going off a tangent, but you're just so cool. What happened to the mitochondria if they weren't effectively transferred? They found it spilled over into the bloodstream, literally small extracellular vesicles and free mitochondria circulating around, and a lot of them home to the heart. Where there were, so then this was a third paper, they create oxidative bursts at the heart that precondition it to protect it against a heart attack. So they had this line in the paper that blew my mind. I think this paper was Crew et al. In Cell Metabolism 2021. They have a line about the state of obesity in the body preparing for the inevitable lipotoxicity and like preconditioning the heart for a heart attack. And there's this image where they actually show the preconditioned heart with the mitochondria versus without. And you can see the infarct size that caused heart attacks in mice. And the dead tissue is just smaller. And I just bring this up because the work you're doing and the biology like this, it's going to give us insights into the precision of how do we tweak mitochondrial transfer and how that has domino effects for the whole body. The reason I'm getting so animated about this and going off on these great nerd tangents is because I think for most people, definitely me, maybe you, when I thought nutrition science when I was 20, I thought this is fluffy. My plate, eat a balanced diet, 5 a day, I know what this is. Then I struggle with my own stuff. And it sounds like you struggle through your own stuff. And then you delve into the metabolic health science and nutrition lifestyle stuff. It is the most interesting and hardest core science there is. And part of my mission, I feel like now in life, is to get people to see that before they get sick. Sorry, that wasn't much of a question. I just needed to.
Two comments on that. One is, for one thing, when we take our organic chemistry and things like that, we're shown these charts that we're supposed to memorize, and that turns out to be a big turnoff. And I think we go down a bad path that way for those of us who learned this stuff in college. And so I think now relating it to human biology, it is really important, and we should be learning it and understanding at a level we never did back when we were in school. But back to your point about mitochondria, believe it or not, it's a field I do follow a lot because, as you know, in the aging field, your mitochondria get damaged over time from all these reactive oxygen species. You wind up with damage. And if you want to live forever, you're going to have to be swapping in good mitochondria. I think I'm a big believer in this, that we'll all have mitochondrial transfers. Well, I'm a little older than you, so I may miss the chance on this, but
you can have mine. I think, go to your lab. We can N equals 2 it.
Yeah, well, what we need to do is, have in reserve a bunch of mitochondria that we can actually put it, because I do think we will want to be swapping out mitochondria to, keep our cells boosted and keep our energy up, and if we want to live forever, or even keep our fatigue down. At least that's my prediction. So I think this mitochondrial transfer stuff is really interesting and probably super important.
Yeah, you heard it here first, folks. Michael Snyder, engineering mitochondrial transfusions for longevity. I'm sure we'll see it in the next 5-10 years.
I'm conflict because I'm an advisor on a company called Matrix that's doing this. That's basically can make gobs of mitochondria, and now they're just poised to be able to put them into people.
Wow, that's really incredible. On the topic of reactive oxygen species, let's talk about antioxidant status. So you mentioned there was a change in antioxidant capacity. Which peak was this? What went on?
Yeah, it was more in the 60s. I mean, I think your oxidative stress does increase throughout your whole life, but at 60s, there's a lot going on there. And, I myself take antioxidants, coenzyme Q, vitamin E, a few things like that to keep it down. And hopefully it works. So that's one of those peaks. Yeah.
Yeah. So on that note, do you think, I know there's skepticism about supplementation. So I think in the ancestral health space, people often go to this argument of, oh, well, did our ancestors do it? Oh, our ancestors didn't take supplement. It's not necessary. It's not needed. I would argue evolution didn't optimize for us to live to 110. And what we see here is a point at time where we might actually need extra defenses. So if I may put you on the spot for like sort of a yes or no question, do you think it's wise after this aging peak to add supplemental antioxidants to the diet, either through supplementation or through a focus on prevalent dietary antioxidants? And if so, what antioxidants do you think are wisest to focus on?
Yeah, I'm 100% believer in this, although I do agree the data is not there. The one area where the data are there is vitamin D. You probably have seen that. The vitamin D supplementation in very large studies, and number of studies now have all shown that that has health benefits as a supplementation.
Yeah.
I think most of us expect these antioxidants will be valuable, but they haven't always been shown as in supplementation. And I think that's where, the skeptics come in and say, well, it's only, it's true in those foods it works, but maybe not as supplementation. Having said that, as I say, I do think we need more rigorous studies, large studies to show, that they do work, and who do they work on and who don't they work on. I think I would imagine people with maximum oxidative stress would benefit the most. And so,
Yeah.
but I think we should be running those studies, I guess.
Yeah. I want to lean into something that is kind of conspicuous that maybe people picked up on is who I'm talking to right now is one of the most rigorous scientists in the world. Your track record speaks for itself. And what you're saying is, I do X, but the data doesn't prove I should do X. And so there's this gap that I think people often tangle with, which is this idea that absence of evidence isn't evidence of absence. So when you come up with a question like I just did, where it's like, should you take supplements for antioxidants after this aging peak? The question you should also wonder is like, well, what evidence will we need to prove without a shadow of a doubt that this benefits you? And I mean, we can come up with the study ideas, but they are tremendously complex. Do you supplement people in a randomized controlled trial for, 30 years and redo this multi-omic study that you did? In theory, you could, but you understand why that hasn't been done. So I think
Right.
a lot of time when making personalized lifestyle choices, it is informed speculation and risk-benefit analysis, which is, I think, a nuance people often overlook. Thoughts?
Yeah, maybe I could add to that, which is we need surrogate markers, especially when you're talking about personalized treatments. And so these days you actually can take antioxidants and supplements and things and see what it does to certain markers for oxidative stress. There are plenty of markers you can measure. They're not routinely measured. You can see some evidence of this from your typical,
Hmm.
medical exam, but they're not that good. If you get one of these Boston heart tests, they measure a lot more oxidative
Yeah.
stress markers. And here I'm conflicted, but I have a company called Iolo that does where you give a little microsample. They measure 650 metabolites, and a bunch of them are oxidative stress markers. So they can track your oxidative stress and say, hey, this is kind of high. And then you can actually take these antioxidants and see for yourself whether you're improving those markers or not. And so I think that's where the world needs to go ultimately anyway, meaning regardless of the big studies, which I think are important, we want to know in general what's going on. But I think at the personal level, that's how we want to treat people. We want to know how you are improving if you take that
Yeah.
supplement, not how Mike Snyder and Nick's improving. That's not too valuable to you. You
Right.
want to know how you improve. And so I think that we need a lot more of these, personalized assays to track all this stuff. And I think the data is pretty good around oxidative stress markers being bad. And I think those are valuable surrogate markers. And so I think at the personal level, you can do something about these things.
Yeah.
It's much like bad glucose, right? High glucose is bad. It's not, and then try to keep your glucose down.
A couple things I want to tap on that we mentioned earlier. The caffeine thing. So which peak was that at? I thought it was at
That
the
was
60 peak, but it
44.
was a
Yeah.
40. Okay, I had that
Yeah.
wrong. So caffeine sensitivity jumps up. So people
We
should
might have seen it
in
also
the
in the
afternoon.
60s as well, but it was definitely big in the 40s, the
Okay.
44 peak.
Yeah. All right. So decaf in the afternoon if you're over 44.
Yeah.
Um,
Maybe
and
even before.
maybe even before, yeah. Well, there was a study, I think it was in European Heart Journal, which I forget what the outcome was. I think it was all-cause mortality, but they found an association, a positive dose response effect with higher coffee, lower mortality, but it was only in morning coffee drinkers. So they grouped people into like before
Oh,
noon
I
and then
didn't see
all day.
that.
So that was
Yeah.
that was interesting. I tend to hit my coffee in the
Yeah,
morning.
there's a lot of studies showing caffeine definitely improves your your a
Caffeine or
number of
coffee?
things.
Because I thought it was, yeah. Well, I guess
Well, I think caffeine actually, I believe. So,
hmm,
but most people get their caffeine through
from coffee.
coffee.
Fair enough.
So
Fair enough.
yeah, that has effects on cortisol, as you may know, and maybe that's how it's working,
Yeah.
amongst other ways. Yeah.
Yeah, I know. There was a couple hypotheses. I think one was the boring one, which is, oh, you have caffeine in the evening, you don't sleep as well, and that can affect longevity. But I think the more interesting one was they were talking about the different antioxidants in coffee. There's actually a lot of really interesting compounds, chlorogenic acid, among others. And we've been talking all about rhythms here. The inflammation markers and oxidative stress markers in your body follow a rhythm. They tend to be higher inflammation in the morning. So there's this idea that if you time the dietary antioxidants actually found in the coffee with these inflammation oxidative stress peaks, it gives it more to damp down. So I don't know if that's the actual mechanism, but it's interesting.
Yeah.
All right. A couple last things I want to get to from this paper. There was an interesting finding or lack thereof about menopause. Now, I realize the finding wasn't powered for that. I would have expected there will be an aging peak associated with menopause in females. Did you see that?
It's there. We decided not to dive in on that because the cohort was fairly small, 109 people. And we didn't want to make conclusions that, would get criticized. So we stayed with more general, stayed with the whole cohort. And to be honest, left that out. We're running studies now to look at the effect of menopause. It'll be much more rigorous, much more robust. So I think it's a really important understudied area, as you know. Hormones change. And in the old days, people used to say, well, there was a study that was misinterpreted that you should not go on hormone replacement therapy because it increases cancer and things. And the whole, that turned into a mess. Now, the word on the street is you should do hormone replacement therapy. It improves your health. But obviously when the female hormones shift, there's huge changes. Everyone's pretty aware of that. But they haven't been well measured like the way we do with these, omics profiles to see in more detail what's going on. So we're diving into that a lot deeper. And so hopefully we'll have a more precise study on what's going on through menopause.
Very interesting. I actually have a funny family anecdote on that. Was my dad is a pretty well-known obstetrician and gynecologist. So when there was this whole thing around hormone replacement therapy, he was always telling my mom as she was getting to her menopause, like, no, you should go on HRT. And then she kind of went with the mainstream narrative at the time, didn't do HRT. And then years later, there's very few times when my mom would say to my dad, okay, you were right. This was one of those times. So he had, validation. But anyway, that aside, thank you so much for discussing the study with me. I know people are going to get a ton out of it. My final questions for you, same as last time, are where can people engage with the primary work and maybe volunteer for studies that you're running? Because I know you're running 1,000,001.
Yeah, well, visit our website. I'm easy to find, Michael Snyder at Stanford, and you'll see the website. We have a list of studies. Some you need to be in the Bay Area for, but some you can be anywhere in the world and be able to participate. Data we think is super important for measuring health and in our case developing new algorithms. So please do visit and participate if you're up for it. I think the aging area, it's going to take, because we're all so different, we're going to need a ton of different people participating to really understand this at a personal level.
Yeah, for sure. So my call to action to everybody listening right now, if you haven't watched part one, go watch part one. If you care about personalized precision medicine, watch this all the way through, share it, because this is groundbreaking stuff. And I couldn't thank you more. Like I said at the beginning of part one, you have hundreds of papers that we could dig into. We had to choose two. So I hope I can get you back at some point in your busy schedule to talk to my audience at a future point in time. But thank you so much for your time. I really appreciate it.
Been my pleasure.